Well, I've got a level 1 interview for you. It's Mr. Greg KH. Can you pronounce your name for me? Because I've heard Kroah-Hartman and Kroah-Hartman, and it's probably a thing.
That's why I go by KH. It's Crow, like the bird, Hartman. So
Kroah-Hartman. Okay. Well, I've definitely gotten that wrong already at least 7 times. But otherwise, I mean, you're the man who needs no introduction, really. I mean, all things Linux, all things, the kernel. I've been using Linux since before I was a teenager, which is kind of an accomplishment. It was, I think, a 1.4 or 1.2, but I didn't get serious about it until like kernel 2.0 and 2.0.36. It was an exciting time for teenage me. So yeah, it's great to have you. You recently did an AMA on Reddit, and so I thought we could sort of pick this up where that left off. If somebody isn't familiar with your work or wants to get the basic questions out of the way, there's the Reddit AMA, which is pretty awesome. But the reason I connected with you is to deliver into your hands Threadripper.
New hardware. I will gladly take donated hardware. I will code for hardware. So
yes. And AMD got on board because it's not something I would have been able to do myself either. But I called AMD and it's like, hey, the man is interested in Threadripper, and they were like, say no more. Here you go. Well, actually, they needed a little bit of an explanation, and then they were like, all right, sounds good. We trust you. So you were able to remote into the system and poke around with it a little bit. You haven't actually gotten hands on the system. I'm shipping it to you, I think today or tomorrow. And it's an MSI Creator TRX40, the AMD 3970X, 32 cores of Insanity, 256 gigabytes of G.Skill memory, and about 1.5 terabytes of a 4-way NVMe RAID. So very fast storage, very, very fast memory, very fast processor. So hopefully that's going to be a lot of fun. Hopefully we could do a follow-up or something like that after you've gotten a little bit more hands-on time to play with it.
Yeah, I'd be glad to. And yes, they'll be used to build kernels. That's all I'm pretty much doing. If you can see, there's a little laptop spinning in the background building kernels right now, too. So.
We're at about 20 seconds, give or take. The only thing I'm worried about, honestly, is the noise level. I think it's pretty good, but you could actually configure it to use less watts, and then it will run a little slower, but also be dramatically even more quieter. But I think it's pretty quiet, I think.
Okay. Well, good. That's one of the keys. I've heard some of those machines are very loud. The kernel self-test maintainer, Shua, has one, and she keeps it in her basement.
Well, we can rebuild it. We have the technology, so I don't. It's exciting. So, what is a day in the life of a kernel maintainer like? Like, what is? I mean, there's a lot of answers in the Reddit AMA, so I don't want to rehash new ground. But how do you manage so many different moving parts? Like, there's got to be like a meta game here that people can learn from in terms of like just structuring events in their life.
Well, yeah. So I do a lot of different things, right? So I do stable kernel releases. I maintain different kernel subsystems, and every once in a while, if I'm really lucky, I can write some new code. So it was Friday afternoon here, so I actually got to write a little new code. So I do different things, right? So mostly I get a ton of email. I average about 1,000 emails a day that I got to do something with. File them off, and then when I want to go and say, okay, I'm going to work on USB patches today, right now, I look at all the USB patches, go through them all, fire them off, build them, test whatever I need to, push them out, and I'm done. And then same thing with stable kernel patches, which I usually carve out an hour or two a day, handle those, push them out, and go. So just carving up things, but it's all email. Everything I do is pretty much just email. I joke, my son, when he was really little, he went to school, he had to draw like a picture of what his father did. He's like, oh, my dad doesn't have a job. He sits at home in his pajamas and does email. So, yeah, that's my job. I don't know what kind of work ethic I'm giving my children, but as they get older, they know better. So
I think that as they get older, they're going to start to realize that there's not really a lot of difference between what you're doing and literally just plugging your brain directly into the internet.
No. So actually, my daughter's given a talk at Linux conferences before, and she's worked at them, and my son's been to them as well. So they kind of know what they do. They're getting better.
Well, I mean, it is true, though, because the critical infrastructure depends on, the wetware doing some processing there. But, as long as you can, replicate that somehow, or, just plug your brain directly into the internet.
I mean, our job is to say no, right? So to say no and find the bug. So a lot of it is just pattern matching, and you see common patterns. The best are patches that are sent to you and you're like, there's no way this can be right. And you read through it and you're like, yes, this is obvious that this person never actually even tested it. So I get to say, why did you send this to me?
My boss was angry and I wanted to send it. And
some things are fun, but normally it's like, okay, that's great. Add it to the system and push it out, and all the test bots go off and run on it, and everybody's happy. But yeah, a maintainer's job is to say no, pretty much. You're an editor. You edit things and you say, hey, why don't you try this, do this instead, or like carve this up into smaller pieces and I'll take 3/4 of it and you can work on the last quarter and things like that.
I think having that kind of exposure to just both the hardware and the software side of things, and being able to see some of the insanity in code, is anything particularly memorable about a hardware bug or a code submission where you look at it and the code looks like super squirrely, and you ask about it and it's like, oh yeah, this is to work. The hardware barely works, so we're just fixing it in software.
That's the job of a kernel, right? So an operating system's job is to make the hardware look uniform to all user space. I mean, Linux is great. You can use your user space program on any different type of processor and it just works, right? That's the job of an operating system. And so a lot of the work we do is papering over these bugs. I mean, there's some infamous bugs or infamous code in the kernel that's like, write a variable, write it again, hit it again, and this time the comment is like, this time I really think the hardware is going to take it, and you hit it the 4th time. There's things like that in there. There's lots of crazy stuff where it's like obvious the hardware designers weren't thinking and they send the data in the wrong way, or best is I just rejected a patch today because there's one new type of chip that for its serial ports, it wants to go everything twice as fast. And there's no way to detect at runtime which one is which. So you have to just guess. I'm like, you can't just guess. We have to figure out some way to dynamically figure this out. Besides, you're not going to build a custom kernel just for this one chip, right? It's like that. It's just dealing with hardware bugs. I mean, it's easier to paper over these issues in software than it is hardware, because spinning a new device, or you got to support older devices. Or the best is you get the clone devices. I mean, there's USB serial chips. These things are dirt cheap, but there's clones of these sub-dollar chips that are barely working too. and so we have to support the clones in a certain way. And they fake out and they look, for all intensive purposes, like the real device, but yet they work a little differently. So we have to kind of poke and prod and guess and see what we're working with.
Yeah, I think I'm familiar with some of those USB serial chips, because on Windows, they got good enough to detect them as counterfeit, but for a while, they would work. And then the company that actually makes them, I think, figured out how to figure out which ones were clones of their hardware, and then the driver stops working. But of course, Linux doesn't care. Linux is just like,
yeah, they came out. They were trying to break them and try to burn them up. And yeah, no, we just said, we'll take the patch, we'll work around it and keep on going. We'll be agnostic there. You bought the hardware, we'll get it to work. But there's lots of devices out there. The fun ones are all the USB devices that have no vendor and no product ID. They're just all zero.
Somebody forgot to flash an EEPROM.
When you realized you could do that, and you get your devices to work properly, that was a field day. So then you didn't have to go buy a vendor ID from the USB.
The takeaway that I want our viewers to have is that literally all computers barely work, and we're talking about fringe peripherals, but I'm looking at what's happening with like NVMe and all this bleeding edge stuff, and it's like, no, things that barely work at the bleeding edge too.
Yeah, so I see the stable. The stable kernel is backporting all the patches, all the fixes from Linus's current tree into all the older kernels that everybody runs all the time. And yeah, we got a patch set saying, here, for NVMe, we finally got this to work, and now we need to backport it all because we need to get it all working properly. And you just look at these fixes and you're like, how did any of this ever work in the first place? And yeah. I mean, that was kind of the way the more it's turtles all the way down, right? The deal we had to mess with Intel chips it's scary that I now know how I thought I knew how chips worked, but they don't. I have no clue. There's an infamous, when we were working on the very first Intel security problems with that, there was this tiny email thread with me and Linus and some core x86 kernel developers and some Intel people. And I wrote, Intel reported this problem. I'm like, how is that physically possible that this is doing this? And Lena said, oh, it's because of this and this and this. And then the x86 kernel developers doesn't work for Intel. So yes, it's also because of this and this. And then the Intel person came back and said, no, you guys are all wrong. Here's how it really works. And I was like, oh no, we are in such trouble here. But there's a whole world underneath that abstraction layer between just how a processor exposes itself to the operating system. We think of these opcodes that processors work on as set in stone, but there's a whole layer of microcode and little tiny virtual machines and other things running inside your processor. And there's like different variants of it, even if it looks like it's the same one. And it's a nightmare down there. And that edge is bleeding through in certain spots when you can see that boundary. And that's when things get really scary. Because you should be able to bleed through there.
It's funny that you mentioned that, because a lot of user space stuff is starting to kind of deal with that. And one place that I've encountered that has been on like the research side, and things like, just doing linear algebra. So like the linear algebra libraries now will do benchmarks of all of the instructions available on your CPU, because even just different CPU families, but also different stepping, like the FMA instructions may be faster than the AVX instructions, or vice versa, depending on what your CPU is. And so there's a lot of different ways to skin the cat in terms of getting linear algebra done. And so with things like OpenBlast, you actually will run the test on your machine. You add things in like the thermal throttling, and it's like this part of the silicon is getting super, super hot. So, the performance is initially great, but after an hour, the performance really isn't as good. And so in user space, you have to do all of this testing, because I'm going to have this computation that's going to run for 3 weeks, and I would like to get it done as soon as possible. You literally don't know until you test your specific chip and your specific configuration.
Yeah, and it's crazy. And then you can have different memory. I mean, the way memory is accessed is different across different processor lines or different motherboards, right? And it's the ordering of the DRAM chips, and it's crazy. You see that a lot. I've talked to people who make build the servers for giant cloud computing systems, and they want to know specifically this CPU stepping. How can I tell that it's different than this other CPU stepping? Because they really kind of do work differently. And then the chip designers will go, no, we didn't change anything. And then the hardware or the software OS people come back and say, no, look, it really did change here between here and here. And we need to know that, because if we can eke out 2% more, that's real money. I mean, when you're doing a computation for 5 weeks, you want to, if you can save a day or two, that's real, right?
Do you have a sense that hardware manufacturers are looking at how the Linux kernel team does things, and just in a matter of like protocol and procedure and testing, but also like how they are setting up their hardware to drive the next generation of hardware? Because it seems to me that because you guys are so organized and have such a clear understanding of what's happening versus the black box of microcode and other operating systems and things like that, that the hardware companies sort of get clued into, oh yeah, maybe we should do this a little bit better and have a 2% savings. And so in a way, the work that you're doing kind of drives the next generation, or do you have a sense of that?
Well, I've worked with the Intel people for years. They started 10, 12 years ago realizing that they needed to invite Linux kernel people together and talk to their core CPU architecture developers and designers, and talk about these things, because we have problems with certain things and they think, well, we should be doing things that we're not doing, right? They've been doing that with other operating systems. I mean, Microsoft's been doing that for decades. So Intel has been doing that for quite a while. I think the last meeting was over a year ago, thanks, because we can't travel right now. But they put us all in a room, and really no managers, and they talk about what they want to do next, and we say what problems we've had, and then they ignore us. So there's some things that they famously ignored us about timer issues. Thomas Gleixner's complained about how timers work for 15 years now, and they still won't do it. Some things take a long time. It took them a decade to give us an IOMMU to virtualize memory stuff. It works. So some things they agree with and some things they don't. But yet it's not what next generation. I mean, chips timeline is like 5-6 years. It's crazy how long the timeline is. Talking to some of the ARM developers, it's like, yeah, okay, the stuff we're doing now, you'll see in a device in 6 years from now. So it's like, and then you forget. We have no idea what we did. And so Intel realized that was a good idea. ARM now realized it. So we've had the past couple of years, we've had a meeting with ARM about the same way. In fact, it happened right before pretty much all the lockdowns happened. We all met in Cambridge for a couple of days and had their engineers talk about things, and we told them what they were doing wrong and such. It was fun. So yes, we do get involved, and they do take they listen to us nicely. Whether they actually do anything or not is something else, because we're just software people. We don't know how the hardware works, right?
Well, I think that you guys know more about how the hardware works than really it would be apparent, because it barely works. And in order for the software to work reliably, you're going to have to deal with all the little edge cases in the hardware. I mean,
yeah, but it's more of a general idea. So they're like, hey, we want to do this type of stuff, and like Linus will say, give me error correction memory always, and they're like, no, we really don't want to, and things like that. Because we don't know how much things cost, right? We don't know how much things cost in silicon, the thing that costs in systems. That we just know what would work really well, and so we advise them.
Do you think companies like Sci5 with RISC-V, where it seems like they're trying to shorten those cycles? I know Linus Torvalds, famous, like everybody wants x86 on the desktop and servers and on the desktop because it's same thing everywhere. But just the general driving a shorter cycle of features in silicon to software availability, and or maybe things like FPGA. Like it seems like a lot is happening between RISC-V and generally available FPGAs, and the cost, even though they're still fantastically expensive, the cost is actually quite a bit less than it was 5 or 6 years ago. Do you see things like that shortening those development cycles to have a path toward better hardware?
I don't know. I like RISC-V. I hope it does well. The code, what we've seen is nice. It needs to scale up in a few certain areas in order to make it a real contender, but in the low end, it's doing really well. But I mean, Linus's famous point is x86 works good in the servers because we have it on the desktop. And his pitch is, if we had a really solid ARM system that we could use on our desktop, then it would be a no-brainer, right? We can never get that. We argued for years and years for PowerPC to finally get us one. They famously did ship me one. It took 220 volts in the US, which I had to plug into my dryer thing. And it sounded like a fire hose, or it sounded like a giant hurricane came on. So I shipped it back. And it came on a pallet. My wife wasn't too happy about that one. So yeah, if you're comfortable and you're used to developing systems on your laptop or your desktop, and then you can roll it off into the cloud and everything works well, because you want to test things locally. Now, as far as the design cycle times, I don't know. I thought 6 years and 5 years was a long time, but hardware people think that's fast. I don't know. I don't know what's all involved there to say that why things take so long, or if they can shorten them. A lot of times you only hear of things in the next year, right? So like I've infamously learned not to talk to my Intel friends and say, hey, which chip should I buy? They're like, oh, the next one's going to be great. Because the software guys get it about a year in advance. And so then before it comes out. And so the hardware guys are like 3 years, 4 years out by designing stuff. I don't know. With FPGAs, it's cool, but you're not going to run FPGA on your desktop, right? On your main system. You're not going to run it in your data center either.
That was one of the things that Apple did with the new Mac Pro that I thought was interesting, is they do actually have an FPGA hardware accelerator to speed visual effects and things like that for people who use Macs for visual effects, and I thought that was really interesting. I mean, it's not super interesting because it comes in a machine that tops out at like $50,000, so like your pallet machine, not a lot of people are buying those. It's not mainstream. I'm not saying it's mainstream, but I did think that was an interesting way that they solved that problem, because there's as much computational horsepower as a desktop computer has between its GPU, even a relatively pedestrian GPU, and the CPU. A lot of just end users can't unlock that performance because their software is just not optimized for it, and so things like video production, it's just not there.
Yeah, and there's a lot of wasted cycles. I mean, infamously, if you can get the data to the CPU spends almost all its time just waiting for memory to come in, right? And then waiting for memory to hit the other third level cache, and then the disk, and network. Network is forever. So you never want to have data across from network. And you can do lots of things to optimize stuff, and highly tuned workloads are great, but then the next generation chip comes out and all those timings go off. And like you say, you have to run these special benchmarks to figure out how to run it best on your workload. It's tricky, right? Hardware people want to sell you the latest chip that goes faster in certain ways. Can you create a general purpose? I mean, GPUs are great. But now they're turning GPUs into, for AI, those computation is just all they want to do that math. They're turning into coprocessors.
Yeah.
And I mean, the Pixel phones have had those for a while. They're doing the PCI cards from different companies. Qualcomm announced one. Habano Labs has been out with one for a while. And then you get a whole bunch of finely tuned stuff that you can just throw math at. And that's cool.
Yeah, because I mean, if you want augmented reality and that kind of processing in a phone that's not going to have a dead battery in an hour, then that also depends on that super rapid like hardware iteration. So and it also turns into a software mess because again, it barely works.
Well, yeah. So I mean, the Pixel phone that had the first coprocessor for the camera was really cool in that it was actually the coprocessor was running Linux. So every time the phone would wake up, you'd shove the whole image of Linux across the whatever bus it was to the little chip, and then it would boot up, and then the camera would start displaying the thing. And I got it really fast. They did it fast, but that was a coprocessor doing specifically tuned stuff running Linux, which was hilarious.
Linux is literally everywhere. I mean, there's no question about that. I mean, at this point, isn't it like on satellites it's definitely on satellites in Earth orbit. It's on satellites that have escaped Earth orbit are in interstellar space, I think, or there was some probe I think that was
I think there is a probe. I'm pretty sure there is. I know we're everywhere else. That's scary how we took over the world. We always joked and then we did it. But
yeah.
Yeah, just that pesky desktop if people care about that. But
it's the hardware company. Oh, I don't know.
You can't, but look, Chrome OS is taking over the desktop. I mean, Chrome OS is, and that's all running Linux really well. And those are top 5 selling laptops for the past 10 years or something crazy.
Yeah, one of my acquaintances has one of the like mid-range Pixel books, and I think it's Crouton that they use with that. Yeah, and it just got some features so the Crouton's not as sandboxed, and it's like, this is actually a really nice computing experience.
Yeah, if only there was some more memory on that disk. So I can't use that. But yeah, that is a neat thing. And like when the first Pixel books came out, or the first Chromebooks came out, I gave it to my daughter, and it's like, if you lose this, I don't really care because it's cheaper than your phone. So, and actually it survived. It's still around. So.
Nice. Well, do you have any productivity tips or any tips for like the next generation? Our audience tends to skew toward people that are in college. I get questions all the time that are like, I'm thinking about computer science, but my university has like 73 computer science degrees. Like, do I need to go hands-on? Do I need the theoretical math degree? And I usually just tell them, it's like, do what you have a passion for, and you'll make a difference.
Yeah, the trick is figuring out what your passion is, right? And that's narrowing it down. So I used to hire people when I worked for a company that I can actually manage people. And I saw if people contributed to an open source project and versus somebody who hadn't in college, it was like a no-brainer. I would take the person who had contributed over who hadn't right away, because I know that, they can work with other people. And that's that's a skill that you need to have for employers, right? You can work with other people, you can communicate well, and you're semi-sane, right? So work on open source projects, but like everybody asks, what can I do in the kernel? It's like, well, there's so many different things. Just find something you're interested in. Like, okay, well, how do I find that? Just build it. I mean, infamously, if you just build our Linux Next tree, which comes out daily, you'll see a compiler warning, and I need to go fix that. Or hey, it didn't boot. I'll go figure that one out. Or why does this work and that doesn't work? Just run our latest stuff, and then that'll take you down this path of figuring out something that you didn't know. I mean, infamously, that's how lots and lots of kernel maintainers own subsystems, because they were like, hey, what's that weird thing over there? And they go down and they figure it out, and then nobody else is maintaining it, and they take it over, and then they're stuck with it for life. But it's figuring out what you want to do with that, and then go with that. So yeah, try different things. But in the kernel, so at my level, I come from an embedded background. Out of college, I started working with printers and other stuff. There's no heavy math at this level. It's all working around hardware bugs, simple math. There's other cool stuff you can do in user space with lots of fun math stuff if you like that. I didn't really like that, but my school was more towards oriented actually it did came from the math department. So I did learn a lot of math, but I didn't like doing the math in programming.
I had a little bit of experience with embedded and printers, and it was with Lexmark gear, and I got to the point where they were developing, it was like the user interface in the printer was developed with Flash, and it was like, I'm good. I'm gonna go this way. I'm gonna go this other way now. I'm good.
Yeah, no, you don't want to mess with that. So, but then those printers now, all Lexmarks, all HP printers, they're all running Linux. I have an HP printer in the corner, and that's funny. So that's how I got into Linux. Actually, I was embedded. I was doing barcode scanners at the time, and I had to test my devices with all different types of operating systems to make sure they worked. And USB wasn't really working on Linux yet, so I tested it out, and it turned out I had a bug in my device, and it made it show up as a 102 button mouse instead of 102 button keyboard, or keyboard. And Windows worked fine, but Linux did not like that. So,
well, I don't know why. I mean, a 102 button mouse sounds actually pretty awesome.
Yeah, it would be good. So that was a firmware bug that I fixed, and then went on from there. But then I realized that I could modify the operating system and get my patches in there, and I went from there. But I came from the bottom up. So instead of coming from the top down, so everybody comes from different sides. It depends on what you like doing that way. But you can find a job. There's so many jobs out there now. I mean, we always joke that you get 5 patches in the kernel and you get a job. It's not really a joke, as long as they're not spelling fixes. You can get a job.
I also tend to recommend that students, like even the ones that are not quote unquote comfortable with hardware. It's funny you mentioned embedded systems, because it's like adopt a hardware project. Like just do a little one, an easy one. Mess around with an Arduino or a Raspberry Pi. Maybe try to read from sensors on one of those. Analog sensors or SPI or digital.
Blinky lights are fun, right?
Yeah, I mean it's so much. Or build a keyboard. Like build your own mechanical keyboard, and that is a great learning experience, because you could, depending on how you do it, you'll learn a little bit about USB and the mechanical parts and the computer science, and you have a reprogrammable nice keyboard. Yeah,
and you learn how to solder, and there's nothing scarier than a software engineer with a soldering iron. Except an electrical engineer with a compiler. That's it.
Software engineers with a software engineer with a soldering iron is powering the next generation of hardware, probably. And that's why it barely works.
Yeah, it barely works. You don't want to see me solder. I can barely do it.
Well, I read that you were an enthusiast of mechanical keyboards. You've got a Cherry Blue Philco 10 keyless, I think.
I do, yes.
Oh, nice. Yeah, I'm a Model M fan, so might be because Lexmark's in my backyard, but I've been using a Model M since before I was a teenager, and I can't use anything else.
Yeah, you get used to what you have, and I think I have a stack of them up there, and my other ones I buy every time I go to Hong Kong. I sadly have a favorite keyboard shop. The same thing in Tokyo. I have my favorite little keyboard shop too, and I have to resist not buying a new one. So I think my son has a couple.
If you are ever at an event with AMD's folks and Scott Wasson is there, he collects keyboards, and he has the most incredible keyboard collection that I have ever seen, and it's just completely nuts. Like anything you would imagine, and it's like I had no idea that I would actually like this, but this actually looks really interesting. He talked me into ordering a Model F, so I've got an IBM Model F. It's a reproduction, but it's on the way. It's being produced. It's
one of those really big, heavy ones with the base like weighs like lead. Oh, those are good.
Yeah, it's all and it's in-key rollover. So my Model M's are not in-key rollover, and that was one of my hardware projects. Was like, let me figure out how I can make this in-key rollover without redoing the plastic. And you could do it with analog sensors. It just takes a little while for the analog inputs to settle, because the way that like the clear plastic overlays are, because it's got a bent back plate. It's only digitally 2-key rollover, but you can measure the resistance in the wires and figure out what the keys are. And have more than one key.
It's still the PS2 connection now, right?
Well, no, you can. There's controllers. So like, there's a Bluetooth mod. If you'd like to have a Bluetooth Model M, you can totally do that.
No, that's scary. Okay. Wow.
You gotta replace the PCB goes out the window because it uses like 700 milliamps, which is really pushing it with those PS2 to USB converters, but it's doable.
PS2 to USB is so scary. I mean, when I worked on the USB protocol when it first came out, and that's what I was doing, USB devices and keyboards and stuff, and it was like, this is insane. But PS2 connections were infamous for frying a motherboard. So, I mean, USB is the way it is because they wanted to make a sub $1 mouse, right?
Yeah.
So that's the way the protocol was, and then the USB keyboard was that way. It's a very dumb, slow protocol that's taken over the world, sadly.
Backward compatibility is another rabbit hole, I imagine, that you guys have to deal with a lot on the kernel, but that is a fun rabbit hole. I mean, I look at some, like what archivists are doing, like some of the stuff that the people at the Internet Archive are doing, where it's like, I'm going to build a special drive for reading from Apple II discs, and they've gotten insanely fast at it. Like, you can read an Apple II disc in like 30 seconds, and it's got like sector maps, and they've put a lifetime of engineering into dealing with old stuff, and that's kind of glamorous, but in the kernel, it's not as glamorous. It's more like unmucking a toilet, because it's like, we're going to keep this old hardware that one guy in the mailing list is still using. We'll keep it in.
That's okay. That's fine. I mean, the people say, oh, we can't send our code in because nobody's going to care about it. I'm like, hey, if there's one person, we'll do it. Infamously, we had a whole sub-architecture of x86 because James Bottomley had one machine. We actually like chipped together to try and form a fund just to get him to unplug the thing. And he finally did. The Voyager system, I think, is finally gone. I mean, I would love to see a few of the architectures go away, but as long as they have active users, gladly support it. We do rip code out of the kernel. It's actually hard to rip things out. And we do that if there's nobody using it. And some of the things we ripped out were like 10 years old by the first version of Linux. So some of the stuff we finally got rid of. And I ripped some stuff out, and then somebody a couple months later said, oh, I really have one of those. I'm like, okay, if you want to maintain it, great, and do it, and we'll handle that. So that's the easy stuff. If you have something and you have somebody who wants to test it and keep it alive, that's great. I mean, Alpha is still around. I'm getting bug reports for Alpha serial drivers still. We messed up something. But
that's impressive.
It's very impressive, and they're still working on those systems. And again, you want to just chip in and buy them something new. But in the amount of power, I can't imagine how much power those things take. So, but our job is to keep these things alive. But backwards compatibility is our whole goal of the kernel. We made this promise, 12, 15 years ago, called the Cambridge Promise, we did in Cambridge, that we will not break backwards compatibility, because we never want you to feel afraid to upgrade to a newer version of the kernel. It's that simple. We want to, if we regress, that's our one rule. You cannot purposefully break something. You can accidentally break something. I mean, that's when Linus gets mad if you purposely break it and you insist that you want to break something. So we rip things out and break things where you never notice. As long as nobody notices, it's fine.
Well, that's definitely been my experience for the better part of using Linux for, gosh, I guess it's like over 20 years at this point. That's scary.
Yeah, but the weird thing is, so you can still run that code from 20 years ago. So I get people that are saying, that have been around for a long time, saying, I can't believe we're still using Unix. Why is this old model that we had from the 70s and 60s still around? That's horrible. We should be doing something new. And yes, so we can run those programs from 20 years ago. But if you look at the code and things we're doing today, radically different. So we just keep adding new features and new support for different things. We could do namespaces, which broke them up into tiny little pieces, which lets us do all the fun container mess. A container there's no such thing as a container from the kernel, but you just piece together all these things and shove it together in different ways, and you can create crazy things like Docker and all those fun stuff. But you don't have to use the Docker model to make containers. You can do network namespaces. You can namespace the time now. I don't know why people want to namespace time. And you can do all of our security models are crazy. There's new security models and the eBPF stuff that they're doing that we now are a microkernel, and people didn't realize that. But yet, if you look from the outside, it looks like our still old, stodgy Unix-like POSIX model. And that will work, but you can also do cool new things as well. And that the idea that there's these cool new things that work differently and take advantage of this new hardware that we have, like NVMe drives are so fast, we have to do different things, right? And what do we do with that? Do we make that memory? Do we make it a drive? What can we do? And you can do some really cool stuff with the IO U-ring stuff that Jan Expo's done now that he took the old PCI flash storage stuff and took the ideas and stuff that he learned there, and made a whole new way to do IO in the kernel asynchronously, really, really, really fast.
Yeah, that's good, because interrupts are not working out for NVMe, it turns out.
Yeah, well, the problem is also traditionally Linux has always been like doing a system call is fast. Really, really fast. And we were like, okay, we can do a system call. We were so much faster than everybody else. But then and it turns out they were so fast because the hardware designers were cheating. And then that was all the whole Spectrum meltdown nightmare. It's like, oh, they were so fast because they weren't actually restoring state across everywhere. They were leaking all this stuff. So then they made us put all these boundaries in the chips and in the operating system to flush all these buffers. And now system calls are slow. Right. So now we have to think, okay, how do we design a system when we are original premise of a system call being fast is not true anymore. The hardware is fast, but thunking between the kernel and the user space is slow now. So how do we do things differently? And IOU ring is that way. You queue up a whole bunch of IO and you give it a whole bunch of things and you just let it go. And it just automatically appears to you in user space and you don't ever have a system call transition there. It's kind of magic and scary, but it works really, really well. And you can get some really insane speeds out of it if you have good hardware, or even some slower hardware works well too. So there's these new things happening in Linux, and we evolve. I mean, we joke it's not intelligent design, or it isn't not intelligent design, it's evolution. And that's the way Linux works. We slowly evolve as to what actually is coming at us. What do we need to change? But to the original point, people don't realize it because they see the old stodgy Unix model that the BSDs and such are still using, and AIX is still using, and they don't realize that. But you can run those apps, and that's great because we want to have that backwards compatibility. Those old system calls are still there. You can add new system calls and do some cool new things too, if you want to.
One of the most amazing things that I like with when I've got a fresh batch of computer science students and I'm teaching them about the layers of complexity and how a lot of complexity is hidden from them and they don't realize it. I usually ask them to start doing like date-time calculations, and then I start poking holes in all of the date-time calculations that they're doing, and then eventually that lecture, that talk ends with them at a terminal doing, I think it's Cal September 1752, and it's like, okay, it's like, no, you don't need to deal with that yourself. You need to let the system sort of deal with that as the introduction to, because there's 2 weeks missing from September of 1752.
Okay, is that the one? Oh, that's not the year that disappeared in Europe.
Yeah, no.
Okay.
Yeah. It's just September 1752 is like 1/2/14, and they're like, that can't be right. I was like, nope, that's accurate.
Well, think about leap seconds. I mean, what do you do with leap seconds? You have to do something. Yeah, time is hard. Time is really, really hard. There's an infamous page out there and saying all the things programmers need to learn about time and the things you get wrong. And one of my first jobs was dealing with time coming out of a little button real-time chip. I had no idea what I was getting myself into. Time is messy.
Yeah, it's deceptively messy too, because there's the elaborate underpinning of a system that's doing a whole bunch for you. One, don't try to bypass that. Rely on that, and that's kind of a parable for the kernel stuff too, because it's like you guys don't break user space, but some people will still go off the rails, and it's like, well, that's not technically user space, so that could break.
It also gets political too, because you have time zones that change boundaries, and you have people. I mean, so time is perfect. It's a messy hardware, physics, and politics all at once, and
and it's like, it's like I'm just a programmer. I can only solve programmer problems.
There's a talk I saw once on. There's a Wall Street Linux conference many years ago, and the guy started out saying, "My father invented time." We're like, "What?" He's like, "No, he worked on GPS chips." We're like, "Oh, okay, all right." So GPS chips are basically keeping time with atomic clocks.
My other favorite story there is how they caught insider trading in Chicago, because they did a trade at the moment something was announced in New York City, and they showed that was superluminal. Like there had to have been superluminal communication or insider trading. And it's like, well,
those guys, I mean, they're shaving microseconds off. They're drilling holes through mountains. They're going microwaves across tops of mountains. It's scary how much those guys. That's a whole other read. Those types of people.
Well, do you have any other hobbies or anything else that you'd like to share? I mean, this has been a wonderful and delightful conversation. I can't tell you how much I appreciate it, and I can't tell you how much I appreciate you letting me build you a Threadripper machine. Because I think you're going to be really excited, both by the just ridiculous horsepower, but also the kitten-like purring of the machine.
I don't really have any hobbies anymore. When I was living in the U.S., I built a kayak, but I don't live near. I live in the Netherlands now. Although there is lots of water around here, you don't really use a kayak that much. So my kayak's in storage. No, I don't really have any hobbies besides this and raising teenagers.
That's probably quite a time sink.
Actually, the oldest one is older than teenagers, so she would get offended if she heard that. With the lockdown, everybody's back home. So.
It's 2020 is going to be a weird year in a few years. Like looking back, it's like that. It's almost like the year didn't really happen exactly. But
I mean, some of us look. I mean, I work from home. I've worked from home for 15 years. I mean, I've always argued that you can do this. It's really good to see companies realize that yes, it can happen, and I'm very happy about that because it seems like most big companies only allow some people to work from home. Like if
Yeah.
you've proven your worth and then you go off, then yeah, we'll let you work from home because we don't want to lose you. The Linux Foundation infamously has never had an office. I mean, for years it was a fax machine above an auto body shop in San Francisco. That was the office. I couldn't even stand up in it. And now there really is an office there, but it's not. I think one person I don't know if anybody goes into it anymore. It's there for meeting rooms. Yeah, we're all virtual, so it works out really, really well. I couldn't go back any other way. But it's good to see that companies are realizing that other people can do it. I mean, Facebook, Twitter, other Google's now saying people work from home now, and that's good.
Yeah, I think that'll be really transformational for the economy, and also just the availability of skills at large, because you no longer have your local talent pool or even a regional talent pool, not even a national talent pool. It's a global talent pool.
Totally. I mean, at SUSE, we worked on the kernel team. We were all around the world. And we were virtual. We got together one time a year and hung out and met each other, but otherwise we were virtual. And then there are ways to do things with remote people and managing that has to be done differently, right? You have to have different rules. And it's just a lot of skill that most managers don't have and they don't feel comfortable with. And it's just a different skill set that people are going to have to come and learn and understand. It's always infamously funny when people say, oh, yes, we want to hire kernel developers, but they must come and work in our office. It's like, wait, a project that's distributed and works through email only all around the world, we don't care where you live, and we must sit in your office. Think about that one for a second. But yeah, it's good. You ship me hardware and I can get stuff working. Some things when you're making a physical device, yes, maybe you need to be in there, but you can also go for meetings, different places, and you can have meetings online, and it works out well. So I hope that it happens for more people that they can do this, because I don't think I could ever go back to working from an office. I don't want to.
There are some people that have that I've encountered in my career that do have a little bit of trouble adjusting to separating like home stuff from work stuff, and just managing their time really is what it comes down to. But
totally, it's a lot. And when in the beginning, my wife makes fun. I had a 1-year-old. I was like, no, I'm carving off my time. This is it. I'm going to go down in the basement in my office and shut the door and work. And then over a couple of years, it's like I hear her upstairs talking to someone. It's like, hey, you're getting coffee. Can I come? You realize that okay, as long as you get your work done and then you get different schedules and work around that, then yeah, you work and you end up working more and things like that. I think there was actually one real scientific study of something in Japan where they had to shut a whole bunch of people down for an office and work from home. It became more productive, but some people don't like it. Infamously, at the Linux Foundation, we had a hard time keeping a lot of people like accountants and HR people, because most accountants and HR people are used to working in offices. And then they start working for us and they're like, wait, what do you mean we're not seeing anybody around? And it's like, for a while, they tried to have a psychological exam that you could pass to see whether you liked working from home or not. And that didn't really work out. So it's a different skill set. Some people like it, some people don't like it. I've worked with people that say, one guy was like, I got dressed, took a shower, got dressed, walked outside the house, walked around the block, came in, and then I worked. That's what I needed to do. Somebody else is like, I stayed in my house and didn't talk to anybody for 2 weeks and realized I needed to take a shower, and I go to a coffee shop. So it's like, somebody I worked with was like, oh, you didn't realize that I had moved to a different state and was hanging out, sitting in the back of college classes while my girlfriend was taking those things. I was like, no, we didn't. So, yeah.
The adventures of kernel developers.
Yeah, adventures of kernel developers. It's, and then, pre-lockdown, you could travel anywhere. And I mean, there's a conference every other week somewhere. And I mean, I used to travel an awful lot. And it doesn't matter. You can work from anywhere, and that works out well too. So, because sometimes you do need to meet people. Sometimes there's cultural issues, and there's just personalities. And once I see you and talk to you, you're not gonna. You put another name to the other side of that email. You're not gonna treat that person as hopefully as like not so. They're not being so rude. You actually know that that person has good intentions. Things like that. Some cultures, Japan was infamous for, I couldn't actually talk to an engineer without a manager in the way first. But once I was introduced, then I could talk to them. So they had to learn and evolve over time. That's changed now, but in the beginning, we spent a lot of time doing cultural things with Asian countries.
The social protocol.
Yes. Social protocol is great. I can tell fun stories all day. There's a fun story about one Taiwanese company.
Well, you can share. We've got time.
Okay, oh, all right. So I went to one Taiwanese company, and they were not sending their code upstream. They had a driver for their chips, and they weren't sending them. And I was like, "Why are you doing this?" And so I went in and talked to them, I spent like half a day talking to them, and here's how the community works, yada yada. Everybody was fine. They didn't really say anything. And then break time happened, and a few people left the room, and then everybody started asking me questions. I was like, "What? What just happened?" And like the managers left. And then it turns out that somebody had said, so the CTO of the company had written some of the first original code for the drivers. And then the managers were really worried that his code that this person wrote would be removed by the community because it was wrong or whatever, but they wanted to preserve face for that stuff. So in the afternoon, I met the CTO because he's the person who brought me in trying to figure out how to solve all these problems because he's working with Linux stuff. They wanted to get our stuff merged. And I told him that. He's like, oh, no, it's not at all. It was a pure cultural internal to their company, and they thought that would disgrace the CTO if his code was removed. He's like, no, my code was horrible. I know it should be removed.
Yeah, the hallmark. Yeah, that's definitely the hallmark of a programmer. You start looking at a project and it's like, oh man, this what clown wrote this? This is just oh wait, this is me. I did this.
Yeah. I trip over that all the time in the kernel. It's like, what is? Oh, that was me 10 years ago. Yes. Well, but that's the whole social issue of saving face, and you have to, as an outsider, come in and say, figure those types of things out, and that's a cultural thing. That's why we travel a lot, which is that's fun.
Well, I guess for my last question, I would ask. So you don't have any hobbies, but have you read any good books or seen any good movies or TV shows or anything that you got a good laugh out of, or anything that you particularly enjoyed? I
read a lot, but I read a bad science fiction to try and fall asleep. So I won't recommend anything there. The new Amazon Unplugged, one with the virtual reality show.
Okay, yeah, I've heard of it. I have not seen it. I'll have to check that out.
That was actually really good. It was really good. I mean, you always cringe when you see technology and futuristic things, but it was done really well. Good plots, good thing. It was a good all-around family thing. I don't like watching scary stuff. My family does. So in the evening, we try and find something that matches all our constitutions. So I have the weakest in the family. So that one kind of met up with that. So that's a good one. So I recommend that. From Amazon. I'm trying to think what else I've watched. Oh, there's there's bad TV. Bad TV is fun. You like mindless bad TV at times. At times like this, sometimes you just want to watch stuff like that.
Yeah, the Stand is doing really well by Stephen King, and
but I can't do that. My daughter and wife were watching that, I think.
I mean, it is sort of I've got a little bit of the cabin fever, and usually I'm basically a shut in anyway. So like you, I'm not really exactly working from home, but I'm it's I don't know. That's a story for another day. But
every country's keeping things different. They're opening this country back up again in a couple of weeks. So it's going to be interesting to see what happens. So
we're starting to here, but our numbers aren't super awesome.
Our numbers are good, but nothing's really changed. Why would they get? What's going to keep them from going bad? I don't know. I worry. Online school, because we have a teenager who's in high school, has worked out really, really well. He works. It works. All his stuff is doing great. He doesn't have tests, but he has lots of homework and assignments. And he's actually doing his guitar lessons online. But this is great. This all works better than me having to. We have to ride our bike around town. So I think I'd like to just see that keep happening for a while, but. We'll see what happens. Some kids can't handle it. So.
Well, thank you again for the interview. I really hope you enjoyed the system. Hopefully we can do a follow-up on that in a couple of weeks. The video card is a Radeon RX 50 600 XT, so AMD GPU, but it's got some hardware bugs, so good. Have fun.
That's good. I mean, I saw your video and you're like, aha, now they're going to have a tester. Yeah. Honestly, we all know what hardware Linus has, and we try never to break that laptop. I've had to buy that laptop before and make sure I never break it. So yes, this will be good.
That will be that'll be nice. There's no there's a so on like for virtualization, the thing that I've been doing for 10 years basically, because I have to support a whole bunch of different things, is I just sort of stuff Windows into its own virtual machine, but I don't get GPU acceleration. And it's funny that coming from the other side, the Windows subsystem for Linux, Microsoft is adding a lot of crap for DirectX in the kernel.
They just I saw those patches this week.
Yeah,
that was great.
Yeah, but I've been
done really well. It's odd. It's an odd hack. Well, so there's two different things. One is they want to do the GPU, right, for compute. And that's their main driver. And then they're talking about doing a Wayland compositor.
Yeah,
but it's fun. Wait till people realize that their workloads on Linux on top of Windows run faster than on Windows itself.
Yes. Yes.
OS X is famous for that. You run Linux in a virtual machine, and your same program runs so much faster than on OS X.
There was a like, this is not really a story to be repeated, but like when second gen Threadripper came out, the CPU topology is so odd because 2 of the NUMA nodes don't have direct access to memory and 2 of them do. That exposes a bug in the Windows kernel. Linux was fine, and so I could actually run.
We've had a lot of weird NUMA's topologies over the years.
On Windows, Microsoft was like, no, everything's fine in the Windows kernel. But Indigo, which is a renderer, so it scales, like there's no cache contention, there's no noisy neighbor, there's no memory access pattern anomaly, because it basically just runs from cache. It's super predictable. And on Windows, Indigo would run worse on a 32-core machine than a 16-core machine. And so I used Linux to demonstrate that the Windows scheduler was awful by running the same version of Indigo between WSL and on Linux to be like, the scheduler is doing something wrong. And then Microsoft was like, oh yeah, it turns out that the logic in the kernel is literally, if the memory is not local to this running process, move it to the next node. And so it'll just endlessly move half the processes
away from those nodes.
Yeah.
Oops. Scheduling's hard. So that's a black art. But yeah. we hit those hardware issues way before they did.
Yes. That is clear. You don't have that problem on third gen Threadripper, like across the board, and I'm really excited to sort of live vicariously with your experiences with that. But if you have any trouble or anything, don't hesitate to reach out. And if the GPU does do anything that's super annoying, I can send you an RX 590 instead. It's an older card, and it's basically end of life. It's the codename Polaris, but the RX 590 is super well supported and does everything absolutely correctly. The main problem for me for virtualization with the 5600 is that the card physically doesn't correctly support function level reset for PCI. And so you have to actually use the card's system management utilities to kill power to the GPU and then bring it back and then like sort of reset the bus at just the right time, and then it's okay. But again, all hardware is just terrible and barely works.
Yes. Oh, that's bad. They could fix that in the BIOS.
You would think, but they've been trying, and I don't seem to be making much progress.
Maybe they don't have access to that line. Okay, that's weird.
Yeah. But like I say, if you have any trouble, just let me know. And I haven't figured out exactly how I'm going to pack it up. Do you have thermal paste? I
don't. I can buy some. Yeah.
I can. I probably can find a tube for you. I don't know if I'm gonna. I might use some foam to just hold the CPU heatsink in place, and then because I don't know how, I'm gonna just do a little bit of testing and see how it goes, because it's a fairly compact system and one side of it is glass, so yeah, it's probably fine. But if you have, like I say, if you have any problems or if there's any any sort of anomalies, just let me know. And in the BIOS, if the BIOS is ever reset or cleared or whatever, there's a GUI in the BIOS for setting like your fan profiles, and so you can pick at like what speeds the fan runs and stuff like that. And you can also, it's not really underclocking, like it's not, you can just say, I want the CPU to only use this many watts, and it's a total bathtub curve. So at like 90% performance, you've had like a 30% reduction in wattage. So
it's so scary, weird. Physics is weird, right?
Yeah. So I feel like the way that the fan curve and stuff is tuned, especially if it's going to be on the floor, you'll probably be happy. But if not, don't be afraid to complain. I can show you some stuff, and you can fine tune it to be however you want. This has been an honor and a pleasure and a privilege for me to be able to interview you, because like I say, I've gotten kind of a lot of mileage out of Linux. kind of sort of built my career around it indirectly, doing consulting and integration and making silly YouTube videos. So, you know, it's fun. It's exciting. And it was really great to have you.
Great. Well, thanks. This was a fun interview. Thanks a lot.
I'm Wendell. This is Level 1. Thanks again to Mr. Greg Kroah-Hartman. This has been awesome.